tutor, and in today's tutorial, it's going to be a continuation of the course MTH106. All right. So far, we've been on the course, we've been dissecting sets. All right. Tonight, we'll be going into something a little bit different from what we've been doing. All right. But we're still going to touch just a little bit on what we did in the last class, just to wrap it up. And we'll be going into set of numbers. All right. So, with this being said, let's hop straight into it. All right. A lot of persons seems not to be online yet. But nevertheless, we just have to continue, and hopefully they will join as the class proceeds. Right, so I'm just gonna switch this up very quickly, and yeah, good to go. MTH 106. Okay, I think yeah, MTH 106. So this network doesn't embarrass us today. God, it seems to be a little bit off. Now, very quickly. All right, just a moment. Fix my material. All right, Miss Omo Lola, great to have you on the stream tonight. Good evening, sir. We are so glad to have you back. Oh, thank you very much, Miss Omola. I'm so happy. I'm so happy to be back as well, and I trust our TMAs are going smoothly. I trust our TMAs. I'm trying to get the remote control for this. I trust our TMAs are going smoothly and perfectly, and I believe a lot of us already know how this thing works, and I believe you all are killing it big time. All right, awesome. So let's just quickly go into tonight's class. All right, it's been a long day. I need to also prepare for tomorrow's class. Now, just like what we have been doing before now, Mr. Edward Kingsley says, "Good evening, sir. Good to see you again. Good to see you again too, Mr. Edward. It's great to have you on the stream." Now, operations on comparable sets. All right, comparable sets. Really, I must say a very big thank you to a lot of students in 100 level second semester, especially. All right, students in 100 level second semester. My special thanks and my special thanks goes to especially students in the 100 level second semester for your prayers, your encouragements, the financial support, the prayers and the encouragement. I do really appreciate. That's why I'm so much eager to get back to work. Just like I did in the group. I had to specifically, all right, mention of some names, and everybody, generally all the students in my private class. All right, seems like they are the one that knows me. Spend time with me, and we get to know each other. Just like what I used to say. It doesn't mean because we are online. I mean, we get to misbehave. All right, it's all about relationship. All right, the class didn't start like this 100 level first semester. We were just very few of us with Mr. Jolas and Mr. Joseph and Miss Justina and Mr. Tilayo. Just very few of us that we started then. All right, but now we are about, if I'm not mistaken, 50 something in the class. All right, it's all about trust, okay, consistency. All right, we can get there, okay, and I really hope to have you all on board till you get to your 400 levels, till you do your masters and PhD. I mean, it's a marathon. It's not something I just want to do and maybe in the next few months I'm done with it. So thank you to everyone. Thank you very much, every one of you guys. I really appreciate your prayers and efforts and encouragements. All right, enough of the pep talk. Let's go straight into tonight's class. Now we have the comparable sets. Okay, it's a continuation of what we have been saying. Right, we've talked about we've talked about interception. All right, we've talked about when we say subset, we've talked about union, we've talked about complement. When we say complement of the set, when you do not have an element in any of the union or maybe in another subset. We've talked about complement, we talked about subsets, we'll also discuss all their symbols. Okay, So tonight, just very quickly as we wrap up on sets, we're just going to talk about the operations or comparable set. Mr. Jolas, is great to have you on the stream. You are welcome, although you came a bit late, but nonetheless, we've not gone far. All right, now the operation of union, intersection, difference, and complement have simple properties when the sets under investigation are comparable. All right, the operation of union, all right, intersection, okay, the comparable sets. All right, now on this, just a quick one. The operations of union, intersection, difference, and complement, all right, have simple properties. Now union, intersection, difference, and complement. All this we've spoken about in our last class. And complement, all right, have simple properties when the sets under investigation, all right, are comparable. Okay, simple properties, all right, when the sets under investigation, meaning the set you are solving for, when it what is investigation, are comparable. Okay, comparable in the sense that in the union you can get your intersection, you can get your subsets, you can get even your difference and complement. All right, such sets under investigation, all right, is said to be simple, is of simple properties when such sets under investigation are comparable. All right, now let's take a look at some theories. Okay, let's consider some theories. Okay, now let's first of all look at this particular theorem, which says let A be a subset of B, then the union intersection of A and B is precisely A. Now it says here A is subset of B. A is a subset of B. All right, meaning that all the elements in A can be found in B. Okay, so A now is a subset. B is a set itself, but A now is a sub. Let me say sub, like something under something, like a subunit. So A is a subset of B. That means the element of A can be found in B. Okay, now if A is a subset of B, now then the union intersection, when we say union now, that means all the elements in A and B makes up the union. All right, so now the union intersection of A and B is precisely A. Now union of A intersection B, all right, is precisely A. All right, meaning that A union B A, which is true. All right, don't forget that when we say A union of A and A union of A intersection B is precisely A. Now this is what this means. Now don't forget, we say when we say union, that means it is the combination of A and B that makes up the union. All right, or better still, A and B can be found in the element of the union. All right, so when you now say intersection A and B, intersection of A is just the element found in B that is also in the union. All right, so that's why it is said here that the intersection, difference, or union of a complement, all right, under A set you are investigating is of simple properties. All right, when they are what? Comparisons between the sets. All right, these are just this is just a very quick detour to tonight's class. All right, it's still basically on what we have been treating in our former class, intersection, union, complement, and a quick one before we head into tonight's class. So let's head straight on the main business for tonight. Okay, so tonight we'll be starting with sets of numbers. Okay, sets of numbers. All right, now we're talking about some sets of numbers, and we are going to be starting very first with real numbers. Okay, real numbers. Now we have real numbers. All right, denoted. Let me use Mr. Jewelers. I'm not sure I understand. Okay, Mr. Jewelers, can you please rephrase the question? He said, is the element that appear in both parts A/B? Is that a contribution, a question, or a suggestion, Mr. Jewelers? All right. So real numbers are denoted with this R. All right. Now, important properties of the real numbers is that, okay, real numbers, basically we are going to be talking about what we are going to be talking about is it's going to be actually real lines, okay, and kind of number lines, okay. Yes, intersection, okay, intersection element that can be found in both. Yes, I think I get the question now. You are right, sir. I think I get the question now. Yes, element that can be. The network is pretty bad tonight. Please let's bear with me. All right, so we're going to be talking about number line. Okay, let me write it like this. We're going to be talking about number line. All right. Yeah. Good evening, Mrs. Offo. But before we get there, before we get to number line, we're going to talk about some one or two things that makes up, all right, a number line. Okay, and the first thing we are starting with is real numbers. All right, real numbers. Okay, now important properties of real number is that it points on a straight line that can be represented by them. Points on a straight line that can be represented by them. All right, let's not forget, we are going to use all this to explain what number line is. Just stick with me. All right, stick with me. Now we refer to this line as a real line. All right, it could be real line, it could be number line. Real line, it could be real line, it could be number line. All right, now let's proceed. Now, a point is called origin. Now, a point, all right, is called origin. All this is what I'm going to use to explain number line or real line. Okay, now I'm just bringing out all this. Let's dissect all this then before we get into the main thing. All right, I was speaking about the real numbers. Now we're talking about a point. What exactly is a point? Okay, when we talk about a real line or a real number line, what exactly is a point? Now the point is said to be the origin, and it is denoted with O. Okay, now another point, usually to the right, 2 represents 1. All right, to the right and to the left, all these will dissect. Okay, now there is a natural way of pair of point on line and the real numbers. All right, pair of points on line and the real numbers. Now, that is, each point will represent a unique real number, that each real number will represent a unique point. Now let's take this down. Points will be represented by, one thing with your material is, as confusing as it might be, you still have to observe it, because your exams are going to be based on those materials. All right, so whatever research you are making out of your material, you still have to submit back to that material. It's just that now that you have made some external research, you are guided to when you can see, so you can easily notice an error and adjust and not fall into it. All right, now point will be represented, all right, by a unique real number. By unique real numbers. All right, now each real number will be represented by a point, meaning pari passu. Points are represented by real numbers and real numbers are represented by points. Let's not be in a rush, we are heading somewhere. Now, points and numbers are interchangeably changeably used. All right, so either you are using points or you are using numbers, you can switch this for each other. Points and numbers are interchangeably used. Now, also we have numbers to the right side of O. I mean, the sides are 1, are called positive numbers. Now, on this number line, we have 2 sides. All right, we have the negative side and we have the positive side. All right, I think all this we are talking about now will make more sense to us by the time I draft out what the real line is like. All right, and all this will start to play back. Okay, now there are 2 sides on the real line. Okay, we have the positive and we have the negative side. The positive and the negative side. All right, now we'll get there. Now, the numbers to the right side of O is referred to the positive numbers, and to the left side of O is referred to the negative numbers. All right, right-sided and left because I'm taking my time to dissect all this. I could have just drawn the diagram and explain all this, but this is, you're not doing it, you're not writing pen on paper. Okay, so if there's an understanding, I believe majority of us now knows how this thing works. All right, there's an understanding of how this thing works. If you can grasp on that understanding, it will guide you, to help guide the way you study. All right, so I'm taking my time to explain all this, and I'm still going to draw it so we can get a comprehensive understanding. All right, grasp comprehensively. All right, so now don't forget that the right side is the positive side on the line number, or the real number or number line. The right side is the positive side. All right, while the left side, to the origin, this is at the center, origin, all right, is, the left side is the negative side. And there are two sides, the positive and the negative. The positive is the right side and the negative is the left side. All right, now let's proceed. And the number 0 itself is neither positive or negative, it is just there. All right, it is neither positive or negative. Now all numbers, whether positive, all numbers whether positive or negative, are referred to as integers. All right, all numbers, whether positive or negative, they are all referred to as integers. Okay, integers. Now I think that's all. Okay, I think just a little bit more before I take the diagram. Just a little bit more before I take the diagram. Now these integers are also referred to as whole numbers. All right, integers are also referred to as whole numbers. All right, integers are also referred to as whole number. Now there are some certain things you need to know about integers. All right, some certain important things you need to know about integers. Now integers are closed under the operation of addition. They are closed under the operation of what? Addition, multiplication, all right, and subtraction. They are closed under these operations. Note this, please. That is, the sum product of difference of two integers is again in integer. All right, the sum of a product, all right, and difference of two integers, product and difference of two integers is still equals, all right, to an integer. Please don't be confused. We said integers are also whole numbers, and they are either negative or positive number that makes up the number line. All right, so do not be confused. All right, that's the first important thing. Let me create more space. Okay, now as integers are closed under the operation of plus, positive, addition, multiplication, and subtraction, under the operation of division, it's a different thing. All right, under the operation of division, integers are not closed. All right, under the operation of division, please, all these points, I need you to pay maximum attention to them. I need you to please jot them down. All right, if you miss anything, if you are just joining the class, you can always come back and go through this class again. All right, now we have that as that. Now before I go into rational numbers and the rules, now our rational natural numbers and prime numbers and irrational numbers and the likes, let me now draw the number line so we can have a better understanding, all right, of what the number line is. All right, for some of us who have been wondering, number line, what exactly are we talking about? So I'm going to sketch what it looks like on the board, and can pay attention. All right, so this is the number line. This is the line, and we said something is at the middle, which is at the central. All right, and we refer to that as 0, neither positive nor negative. Is this centralized? Okay, no, I'm not sure. Is this in the center? I'm not sure it is. Let me just try and make it centralized. Okay, I think yeah, it's better. Stella said yes. Sorry, I've already gone to erase it. I think here is better now, if I'm not mistaken. So now is 0, neither here or there. It is just neutral, standing on its own. It is neutral. All right, and we said there are two sides. We have the right hand side. This is my right. So let me indicate with let me use a blue marker. So we have the right hand side and we have the left hand side. The left hand side. All right, so we said something about points. All right, points. Now let's begin to get the points. Now we have, let me do 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right, now on the left hand side we said they are negative numbers. Awesome. Mr. Jella said to the right hand side they are normal numbers. Awesome. Yes, to the right hand side we have the positive numbers. Okay, this is my right. It could be here because you're facing the camera. Awesome. Thank you very much, Mr. Jewelers. Miss Blessing is not on this stream, and I'm wondering why. She's one of the very active students. Okay, all these faces are okay. Miss Blessing, you are even here. What's going on? So you are cold in tonight's class. Mr. Edward too. Mr. Edward is I think Mr. Edward joined us recently. Miss Omolola too, I think she joined recently. Okay, Mr. Tinkit has been with us for quite a while. Miss Titi is not on this stream. Uh, okay, Miss Blessing, what's going on? You are here, but you are a little bit cold. That's unlike you. All right. So, thank you, Mr. Jolas. To the right answer, we have the positive numbers. All right. So we don't have to write plus. Mathematically, when you see number, any number standing alone, it's showing that it's without minus. That means it's not a negative number. It's automatically a positive number. All right. So let me denote this with what color? Okay, let me use color black. So I have 1, 2, 3, 4, 5. All right. It's a classroom. All right. I don't want us to be cold. We are supposed to make this class very interactive. It's a classroom. All right. And to this side is the left hand side, which is our negative numbers. All right. So let me write 1, 2, 3, 4, 5. Now let me now use this minus, 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 minus. Okay. Now we have all the theory part I have been explaining to us. Can we now see that I is plain now? Is becoming clear to us. The right side, the left side, the negative and the positive side. All right. Now this is the number line. This is number line. Okay. Now all this one now, all this they are referred to as integers. Integers. Okay. All this now they are referred to as integers. Okay. Now here is the number line. I believe this is clear enough. Is it? So can I erase this? Okay. So let me quickly erase this so we can proceed. Miss Amolola. Miss Amolola said copies. Okay, okay. So let me just take it. Let me take a chill pill for now. Because I can take a nap. Maybe by the time I sleep and wake up, we'll be ready to continue. Yes, you are very right, man. The you know, and that's how this how it's going to continue. Okay. So that's why in 100 level first semester, I'm always of the opinion that we need to sit tight, because just like what the Bible even said, that a day, the evil of a day is enough for that day. All right. So it's to be very very challenging if you had issues in your first semester. All right, 100 level, and you're now bringing it into your second semester 100 level. All right, and second semester 100 level itself has its own issues. All right. So even when you are done with MTH106, you still have statistics, STT 201, where you begin to do tables. Yes, it's getting tough, it's getting interesting. Now it gets interesting in the sense that if your appetite for consistent study is increasing, all right, the level at which the appetite for your studying is, if the level at which your appetite for consistent and authentic study is the same thing or even above your level of challenge of study, then the whole thing becomes interesting. You begin to realize that me that used to be scared of mathematics, am I even the one teaching others? Yes, am I even the one teaching others mathematics? It's very possible. What you just need is to give it a consistent, continuity and consistency. That was what matters. All right. And before you know it, you start making things happen. So let's continue. Let's move on. Now we have rational numbers. We have rational numbers. Okay. And I think that's what she wanted to write. Yes, Mr. Elini. Now we have rational numbers. All right. Rational numbers are represented with Q. Okay. Now rational numbers are those real numbers. All right. Real numbers. All right. They are those real numbers. All right. Real numbers which can be expressed as the ratio of two integers, which can be expressed as the ratio of two integers. Integers. I don't know why I call it jars or gas. All right. But I believe we can see what's on the board clearly. All right. Rational numbers denoted by Q, they are those real numbers which can be expressed as the ratio of two integers. All right. Integers. Okay. So we have that as that. Now, example, e.g., we have just a moment. I think my probation is giving me some. Okay, right. Now, examples are 1 over 3. We have 5 over 6. We have minus 7 over 12. All right. Can we give me more examples of rational numbers? All right. Can I get more examples from the class? Can I get more example? Can I get more examples from the class? Examples of rational numbers. 6 divided by 3. No, no, that's not correct. Now pay attention to something. The numerator and denominator. Now pay attention to the numerator and the denominator. The denominator is bigger than the numerator. All right, you guys say no, this one has to be bigger. Miss Blessing, you get a hand. Yes, 1 over 5. It's not bad. Okay, yeah, that's a good one. Okay, not bad. Yes, yes, 3 over 6. Okay, yes, yes. Mr. Jola is still there. Miss Omolola, what about you? Mr. Jolas, Mr. Free Tech Up, Miss Ofo Chidiogo Ofo, what about you? Okay, Miss Abisola, what about you? An example of rational number. All right, Miss Omolola, Mr. Tinkit, Mr. Emmy. Okay, I need all of us to participate. Awesome. 3 over 7, 5 over 7, yes. Awesome, yes. Thank you very much. We all have spoken well. All right, so we have that on rational number. Now, for purpose of explanation, okay, real numbers are equated to real numbers are equated to what we call P over Q. Okay, they are equated to what we call P over Q, with the numerator on the top and the denominator below. All right, just like what we have here, numerator and the denominator. All right, now the rule is that P and Q must be integers and Q must not be equal to 0. All right, Q, P and Q must be integers and P slash Q must not be equal to 0. All right, just like what we have here, and P and Q must not be equal to 0. So just some certain rules we should pay attention to when we talk about rational numbers. All right, and we denote rational number with Q, which we have done already. Okay. All right, rational numbers. All right, so we have that as that. Now you need to know that rational numbers are closed not only under the operation of addition, multiplication, and subtraction, but also under the operation of division. All right, closed rational number, that means Q is equal to closed under the operation of plus, minus, multiplication, and okay, all right, unlike what we have in the other time, when it comes to rational number, it's closed under all these operations. All right, now let's talk about natural numbers now. All we have on rational numbers. Now let's talk about natural numbers. All right, now natural number is denoted by n. All right, just like we have Q for rational numbers. Now for natural numbers, they are what we refer to as positive integers. All right, positive integers. All right, and they are denoted by n. Okay, and we have examples. Let me not even write it. What are the examples of the natural numbers? Please, I want the class to give us examples of natural numbers. Okay, I'll go get some water because I feel kind of dehydrated right now. So while I go get my water, and I want us to give me an example. Give example of natural numbers. Oh, thank you, Jesus. Awesome. I can see some amazing responses already. Mr. Edward, yes, thank you. Miss Blessing, thank you for that. Awesome, awesome. Yes, awesome. Very well, very well. Let's keep the answers rolling in. They are normal numbers. Yes, that's why we call them natural. All right, that's why we call them natural. Yes, thank you very much for that, Mr. Edward. Mr. Edward, what do you mean USC? I'm not sure I understand what you mean by USC. Are you trying to make a contribution? You're asking a question or a suggestion? UCW, UWC. Okay. All right. Awesome. We're all doing a great job tonight. We're all doing a great job tonight. Let's keep this up. Oh my goodness. So I missed it totally. Okay, it's trying to say you are welcome. Oh my goodness. So sorry. So sorry. I think I'm always saying it. It's not my fault. I'm of the opinion that this is a classroom. All right. Anything you are saying, I need you to type it in full. You know, one of the reasons why I insisted that we use YouTube, because one of the critics I got when this classroom of a thing is just starting, all right, is the complaint that students will say, YouTube, we cannot ask questions the way we want, we cannot interrupt. A lot of students has issues with expressing themselves, all right. So if you are in the class now, maybe you are on Telegram class, you quickly talk, you quickly say this, you quickly say that, come to YouTube, come and type it. All those things you want to say, type it. It will not only help you to get better in expressing yourself in written form. All right, you can express yourself, you can talk, fine, but express yourself. It's not what you talk, it's not what you say that you write. There's some grammatical statements and errors you make, you can't put them into writing. But on YouTube now, it helps you, it enhances your spelling ability. You want to write something now, you have to be particular about what you are spelling, because if I sit, I will draw your attention and you have to correct it, because in your exams you will type these things. So and please, don't use WC. Write it in full. You are welcome, Mr. What's his name? Mr. Edward. Write it in full, please. Next time. I don't welcome abbreviation at all. Okay, awesome. So let's just continue. Mr. Jones is back. I think he went, maybe he went to ease himself or something. At least now he's back. Okay, now we have, everybody has contributed wonderfully. All right. So we have 1, 2, 3, 4, 5, 6 till infinity. Just like what Mr. Frank said, they are normal numbers. All right. Now, it is said here that the natural numbers were the first number system. All right. The first number system developed all right, and at a certain time they were used primarily for what? For counting. All right, there was a certain time that the only thing they were used for was for counting. All right, this natural number set is said to be the first number system developed. All right, so we have that as that. Now, and they are also closed under the operation of they are closed under the operation of addition and multiplication. Addition and multiplication. Now let's talk about prime numbers. Prime. All right. Here they are natural number excluding 1. All right, they are denoted by P. All right, and they are natural numbers excluding. So when we say natural number excluding 1, please can we give me examples of prime numbers? Can we please give me examples if we say prime numbers are natural numbers excluding 1? So what are the examples of prime numbers? Very quickly, please. Let's get this rolling while I erase the board and get ready for irrational numbers. So what are the examples of prime numbers, please? Awesome. Yes, awesome. Thank you very much. Awesome. Awesome. Yeah. Thank you very much. It's just, all right. It's just, all right. It's just, we have that as that. We have prime numbers excluding, all right. Now, let's talk about irrational numbers. Irrational numbers. Awesome. Yes. Thank you very much, everyone. Awesome. Mr. Onfo. I think I'm seeing that name for the very first time on the stream. It's good to have you on the stream. All right. Now, irrational numbers are those real numbers which are not rational. All right. Irrational numbers are said to be Q, denoted with Q. All right. And there are those real numbers that are not rational. Okay, irrational numbers are those real numbers that are not rational. Okay, now the set of irrational number is the complement of rational numbers. When we say complement, what do we mean? When we say A complement B, what do we mean? Very quickly. This is what we treated in our last class in sets. When we say A complements B or A complements C, now they are using that same thing. All right? You can imagine they are bringing set theory now into real numbers, set of numbers. Now, here they are telling us that set of irrational numbers is the complement of the set of rational numbers. All right, I'm waiting for a response. When we say complement, what do we mean? When we say A complements B, What are we talking about? In set theory. Nobody should go and search Google. I'm already seeing the attendance reducing. In the twinkling of an eye, when we say complement, we know what intersection is, right? We know what subset, we know what union is. When we say A complement B, what are we talking about? A rational number is denoted with Q. Are we together? I'm waiting for a response. When we say complement, who is this person? Miss Omolola. That is the Ma, is that what we talked about in set theory? That's not what we talked about in set theory. When we say A complement B, what are we talking about? Mr. Jolas, I'm with you. The class has gone silent. What's going on? I asked a question. Nobody has answered me. Oh. Miss Titi only made an attempt. Miss Titi only. Okay, just a moment. I think there's a little bit of discrepancies here. I'm trying to resolve this because I have Q as a rational number. But I'm just trying to resolve this discrepancy. All right. Okay, people are responding to my question. Mr. Fred, it's great to have you on the stream. I asked the question, when you say A complement B, all right, when we say A complement B in set theory, what are we talking about? Mr. Zola said, I got the answer. Okay, it's rational. Now, I think Ms. Blessing wanted to write, if irrational is Q, then rational is also Q. How can we differentiate it? That's what I'm trying to resolve now. That's what exactly I'm trying to resolve now. I can sense some discrepancies. Because our materials, all right, most time okay, from what I can see here, all right, from what I can see here is a little bit quite complicated, but we just have to have an headway. According to the material, our material, it says Q, all right, but let's not forget we said something about PQ the other time, all right, and we said this is the numerator, um, the denominator deno and numerator. All right. So this now, actually, according to what I have here, the material says it is Q. All right, which is not, it can't be possible. All right, it's supposed to be P, but we'll leave that as kind of tentative because from my research here, some are still referring to it as Q, and while some are referring to it as P. All right, but I'm of the opinion that since the rational number is Q, then the rational number should be P. All right, I'm of the opinion that this should be P since the rational number is Q. Okay. Now, about the complement, since only Mr. Jolas is the person that answered it, let me see, let me check Mr. Jolas' answer before Mr. Jolas will sue me. Now, Mr. Jolas, yes. Now, Mr. Blessing, you have a very good question. But do you remember we used something like this? All right. Do you remember we used something like this? P all over Q. All right. If you say prime is P, you are correct. All right. But when we talk about rational and irrational numbers, it can only be two. P, Q. All right. Rational and irrational number, it can only be two, which is PQ. Okay. Prime is a different thing on its own, just like we have natural numbers. All right. So on this, we are going to settle for this. We all can still go and make our research, and let's come back tomorrow because we're having another class tomorrow. So on this note, we are going to denote an irrational number with P. All right, and we have the rational number as Q. Okay, but we can still go and make our research, and we all can come back to this tomorrow. All right. Now, when I ask the question of complements, when we say complements, all right, before we can talk about complements, there has to be a universe. There has to be a union. Okay. There has to be what we call universal sets. All right, and this universal set is what we refer to as the union. Okay. Now, when we say A complement, what is the complement of A? Now, if this is the union, this is the union. 1, 2, 3, 4, 5, and A is equals to 7, 5, 3, 2. All right. Now, complement now is that this A, what I think that is in this A that you can't find in the union. All right. A complement is 7. Okay, we have 5, we have 3, we have 2, and we have 1. All right. There's a universal set. Okay. Now, A complements now are the things that does not, all right, belong to the universe but are found in A. Okay? Or for example, if A is equals 2, 4, 5, A complement now is 3, 2, 3, 1, 7. All right? The things that are not found in A, which is like the universal set of A complements. So, Mr. Jolas, when you said it's yes, I hope I've clarified. Oluwa, I'm asking Kobayo. I'm asking Kobayo. Sorry for I have to speak Yoruba. Please, okay, now. Okay, on this note, this night, let's all go to bed. Okay? Tomorrow morning, we'll continue from, we are not done with, I said tomorrow morning, tomorrow class, we'll continue from where we stopped this night. We'll continue from complements, and we'll also talk about rational and irrational number, what to denote them with. All right? Is that okay? Let's hold it here. Let's leave it here like this for tonight. So tomorrow, in tomorrow's class, it's not about how fast we are running, all right? It's about how well we are moving. Okay? So on this note, we call it the wrap for tonight. And tomorrow, properly, we will dissect all this together. And I believe that is a good suggestion. Yeah, a lot of us are already came back from work with a lot of stress and everything. let's let's put it that. Let's stop here for tonight. Let's not overload ourselves. Okay. Okay. So thank you very much, everyone. Thank you, Miss Blessing. Thank you, Mr. Edward. Thank you, Miss Omolola. Thank you, Mr. Jewelers. Thank you. I think Mr. Free Tech has gone to bed. Miss Justina, you are on the stream tonight. It's been a while. Thought you are good, man. Okay, Miss Justina, thank you. Mr. Onfor, thank you. Mr. Free Tech Hub, thank you. All right, so thank you very much, everyone. Let's have a wonderful night rest. I look forward to seeing you in the class tomorrow. Good night.